Imagine a single potato nestled in the rich soil of Idaho's vast plains, blissfully unaware of its destiny. This humble tuber, along with millions of its kin, is destined for greatness in the world's largest potato chip factory. But before it can fulfill its crispy fate, it must first survive the journey from field to factory. The sprawling potato fields that supply this culinary colossus stretch as far as the eye can see. Row upon row of lush green plants sway gently in the breeze, their leaves concealing the treasure growing beneath. These fields are not just any farmland, they're the lifeblood of the chip industry, carefully cultivated to produce the perfect potatoes for our favorite snacks. Nature takes its course as our potato grows, drawing nutrients from the soil and energy from the sun. But this peaceful existence is about to be disrupted by the marvels of modern agriculture. As harvest time approaches, an army of mechanical harvesters descends upon the fields. These massive machines, guided by GPS technology, efficiently uproot the potatoes with minimal damage. The contrast between the potato's natural growth and the industrial harvest is stark. Where once there was the gentle touch of a farmer's hands, now there are conveyor belts and sorting machines. Our potato is suddenly thrust into a world of metal and motion, joining thousands of others on a high-speed journey. Not every potato is destined for chip stardom. A rigorous selection process ensures that only the cream of the crop makes it to the factory. Optical sorters use advanced imaging technology to scan each potato, checking for size, shape, and any imperfections. Potatoes with the right qualities, typically varieties like Russet Burbank or Atlantic, are set aside for chip production. The sheer scale of this operation is mind-boggling. On average, this single factory processes over 500,000 pounds of potatoes every day. That's enough to fill more than 6 Olympic-sized swimming pools. Our little hero is just one among millions. Yet its journey is unique and crucial to the final product. As our potato passes through each stage of inspection, the anticipation builds. Will it meet the exacting standards required for chip production? Bruised or misshapen potatoes are diverted for other uses, but our protagonist remains in the running. It's subjected to tests for sugar content and starch levels, critical factors that will determine its ability to fry into the perfect chip. Finally, after a gauntlet of tests and sorting, our potato emerges victorious. It has passed inspection and is deemed worthy of becoming a chip. As it's gently loaded onto the conveyor belt, heading into the factory proper, one can almost imagine a sigh of relief from our plucky spud. But this is just the beginning. The factory looms ahead, a world of industrial titans awaiting our potatoes' arrival. Enormous washing machines, high-speed slicers, and bubbling fry vats loom on the horizon. Our potato has survived the fields and the sorting, but its greatest challenges lie ahead. As the factory doors open to receive the day's harvest, our potato is about to embark on the next phase of its transformation. The world of stainless steel and precision engineering beckons, promising to turn this humble tuber into a crispy, golden snack beloved by millions. The journey from soil to bag is far from over, and the most exciting part is yet to come. As our potato crosses the threshold into the factory, it's about to face its first major challenge. Did you know that the washing process in a potato chip factory uses enough water daily to fill an Olympic-sized swimming pool? This isn't just a quick rinse. It's an intense ordeal that can make or break a potato's chip potential. Cleanliness isn't just next to godliness in chip production, it's an absolute necessity. The potatoes that arrive at the factory, including our plucky protagonist, are covered in soil, debris, and potentially harmful microorganisms. Any impurities left on the skin could compromise the quality and safety of the final product. That's why the washing process is so crucial. It's the first line of defense in ensuring that only the cleanest, safest potatoes make it through to become chips. Our potato is about to experience a wash unlike any other. As it's conveyed into the first of several enormous washing machines, it's hit with powerful jets of water from all angles. The force of the water is carefully calibrated, strong enough to blast away dirt and debris, but not so strong that it damages the delicate skin. The potato is tumbled and tossed in this aquatic assault, spinning through a maze of brushes and water sprays. But the washing process isn't without risks. Some potatoes, especially those that might have been slightly bruised during harvesting, can be damaged by the intense washing. The high-pressure water jets can exacerbate existing weak spots, potentially causing the potato to break apart. Our hero potato must navigate this watery gauntlet carefully to emerge intact on the other side. The technology behind this washing process is a marvel of modern engineering. Advanced sensors constantly monitor the water quality, adjusting the pH levels and chemical composition to ensure optimal cleaning. Specialized brushes with varying bristle strengths work in tandem with the water jets to scrub away stubborn soil without damaging the potato's skin. UV light treatment is often employed as an additional step to eliminate any lingering microorganisms. The sheer volume of water used in this process is staggering. A single large-scale chip factory can use upwards of 500,000 gallons of water per day just for washing potatoes. That's equivalent to the amount of water used by about 4,000 average American households in a day. However, sustainability is a growing concern in the industry. Many factories are implementing advanced water recycling systems that can reclaim up to 80% of the water used in the washing process. This recycled water is treated and used for non-food contact purposes, significantly reducing the overall water footprint of the operation. As our potato tumbles through the washing system, the suspense builds. Will it survive the intense scrubbing and spraying? Each turn in the washer brings a new challenge. A particularly vigorous brush here, a high-pressure spray there. The potato spins and bounces, carried along by the torrent of water and the conveyor system. It's a wild ride, reminiscent of the most intense water park attractions, but with much higher stakes. Finally, after what seems like an eternity of washing, our potato emerges on the other side. It's undergone a remarkable transformation. The earthy brown skin is now a clean, pale hue. Every speck of dirt, every trace of field debris has been washed away. Our potato gleams under the factory lights, a testament to the thoroughness of the washing process. But this is just the beginning of its journey. While the potato may be clean, it's far from ready to become a chip. As it moves along the conveyor belt, dripping with residual water, it faces its next challenge. The peeling station looms ahead, where our potato will be stripped of its newly cleaned skin. The transformation from humble tuber to crispy snack is well underway, and each step brings new trials and triumphs for our unlikely hero. Our freshly washed potato is about to face a challenge that will test its very structure. Imagine being able to turn a whole potato into hundreds of perfectly uniform slices in mere seconds. This isn't science fiction, it's the reality of modern chip production, where consistency is measured in micrometers. As our potato advances on the conveyor belt, it approaches a series of high-speed peeling and slicing machines. These marvels of engineering are designed to transform whole potatoes into chip-ready slices with incredible speed and precision. The peeling process comes first, where rotating blades quickly remove the skin, leaving the potato's flesh exposed and ready for slicing. But this process isn't without risks. The peelers must be carefully calibrated to remove just enough skin without wasting too much of the potato's edible portion. Too aggressive and valuable potato flesh is lost. Too gentle, and remnants of skin could compromise the quality of the final chip. Our potato must navigate this gauntlet flawlessly to move on to the next stage. The real magic happens in the slicing machines. These devices are technological marvels, capable of cutting potatoes into wafer-thin slices with astonishing speed and consistency. The blades spin at incredibly high speeds, often making thousands of cuts per minute. As our potato approaches the slicer, it's guided into position by a series of rollers and guides. The technology ensuring uniform thickness is truly remarkable. Laser sensors continuously monitor the position of the potato and adjust the cutting mechanism in real time. This ensures that each slice is cut to the exact same thickness, typically between 1.3 to 1.7 millimeters. Even a slight variation in thickness can affect how the chip fries, potentially leading to uneven cooking or texture. The speed of this process is mind-boggling. In a large-scale chip factory, slicing machines can process up to 300,000 pounds of potatoes per hour. That's equivalent to the weight of about 20 elephants, all transformed into perfect slices in just 60 minutes. Despite this incredible speed, the precision remains impeccable, with each slice meeting exacting standards. However, not every potato makes it through this process unscathed. The high-speed cutting can sometimes lead to damaged or irregular slices. These imperfect cuts are quickly identified by optical sorting systems and removed from the production line. On average, about 5 to 10% of potato material is lost during the peeling and slicing process. While this may seem high, it's a necessary sacrifice to ensure only the highest quality slices make it to the fryer. As our potato approaches the critical moment of slicing, the anticipation builds. Will it yield the perfect slices needed for premium chips? In the blink of an eye, it happens. Our potato is instantly transformed from a single solid tuber into hundreds of uniform, translucent slices. Each slice is a testament to the precision of modern food processing technology, ready to become a crispy, golden chip. But the journey is far from over. These perfectly cut slices now face their next challenge, the intense heat of the fryer. As they're conveyed towards the bubbling oil, each slice carries the potential to become the perfect chip. The transformation from humble potato to beloved snack is well underway, with each step bringing new marvels of modern food production. The slices move on, their destiny now inexorably linked to the frying process ahead. The precision cut by the slicers has set the stage. But it's the frying that will truly bring out the flavor and texture that chip lovers crave. Our potato, now multiplied into hundreds of uniform slices, is about to face its most intense trial yet in the bubbling cauldrons of oil that await. Our potato slices hover on the brink of transformation. But here's a surprising fact. The oil they're about to plunge into isn't just for cooking. It's a carefully chosen flavor enhancer that can make or break the final product. The next few minutes will determine whether these slices become the chips that fly off store shelves or end up as rejects. As our perfectly cut potato slices approach the frying vats, they're about to undergo the most critical stage of their transformation. Frying isn't just about cooking, it's the process that gives potato chips their signature crunch, golden color, and irresistible flavor. The importance of this step cannot be overstated. It's where the magic truly happens. The frying area of the factory is a carefully controlled environment. Massive stainless steel vats filled with hot oil stretch as far as the eye can see. The air is thick with the aroma of cooking oil and potato. As our slices enter this arena, they're immediately enveloped by oil heated to precisely 350 degrees, 176 degrees Celsius. This temperature is crucial. Too low, and the chips will be greasy and pale. Too high, and they'll burn before cooking through. Timing is everything in this process. The potato slices spend just 3 minutes in the fryer. But during this brief period, a complex series of chemical reactions occurs. As the water in the potato slices rapidly evaporates, it's replaced by oil, creating the crispy texture we all love. Meanwhile, the high heat causes the sugars in the potato to caramelize, resulting in that appealing golden brown color. The science behind achieving the perfect crunch is fascinating. As the potato slices fry, their cell walls break down, releasing starch molecules. These molecules interact with the hot oil to form a crisp outer layer. Simultaneously, the moisture inside the slice turns to steam, creating tiny pockets of air. It's this combination of crisp exterior and airy interior that gives potato chips their satisfying crunch. The type of oil used in frying plays a crucial role in both flavor and health considerations. Many large-scale chip producers have switched from traditional vegetable oils to healthier alternatives like sunflower or canola oil. These oils not only have a higher smoke point, making them ideal for frying, but they also contain less saturated fat. Some factories even use a blend of oils to achieve the perfect balance of flavor and nutritional profile. As our potato slices navigate the frying process, they face numerous challenges. The sheer volume of chips being fried simultaneously, often up to 1,000 pounds per hour, means that maintaining consistent temperature and oil quality is a constant battle. Sophisticated sensors and computer-controlled systems work tirelessly to adjust heat levels and oil flow, ensuring each batch is fried to perfection. The journey through the fryer is not without peril. Some slices may stick together, resulting in unevenly cooked chips. Others might curl or fold, creating pockets that retain too much oil. Constant motion in the fryer, achieved through specially designed conveyor systems, helps minimize these issues. Still, not every slice will make it through unscathed. After what seems like an eternity, but is really just 3 minutes, our potato slices emerge from the oil transformed. They're no longer pale and limp, but golden brown and crispy. As they're lifted from the fryer, excess oil is shaken off, leaving behind perfectly cooked potato chips. The metamorphosis from humble potato to crunchy snack is nearly complete. But the journey isn't over yet. While our chips may look and feel perfect, they're still missing a crucial element: flavor. As they move along the conveyor belt, still warm from the fryer, they're headed towards the seasoning station. Here, they'll receive the final touch that will determine their ultimate flavor profile. Whether destined to be classic salted, tangy barbecue, or exotic new flavors, the seasoning process is where each chip truly comes into its own. The crispy canvas is ready. Now it's time to add the flavor that will make these chips irresistible to snack lovers everywhere. As our chips approach the seasoning station, they're about to enter a world where precision meets passion. Did you know that the difference between a good chip and an extraordinary one often comes down to mere micrograms of seasoning? It's a delicate dance of flavor that can make or break a batch of millions. The seasoning area of the factory is a marvel of engineering and culinary science. Massive drums rotate slowly, their interiors lined with specially designed baffles and channels. These aren't just simple containers. They're highly sophisticated systems capable of applying seasoning with microscopic accuracy to millions of chips every hour. But evenly coating such a vast quantity of chips presents a monumental challenge. Each chip must receive the perfect amount of seasoning, not too much, not too little. And it must be distributed evenly across the entire surface. The slightest variation can result in inconsistent flavor, disappointing consumers, and potentially damaging the brand's reputation. To overcome this challenge, the factory employs cutting-edge technology. Electrostatic seasoning systems use charged particles to ensure the seasoning adheres evenly to each chip. As the chips tumble gently in the rotating drums, they pass through a fine mist of seasoning. The charged particles are attracted to the surface of the chips, creating a uniform coating that sticks even after packaging and transportation. The science behind creating unique flavors is equally impressive. Food scientists and flavor experts work tirelessly to develop new and exciting taste profiles. They use a combination of natural and artificial ingredients, carefully balancing sweet, salty, sour, and umami notes to create flavors that tantalize the taste buds. Some flavors might contain over 20 different ingredients, each precisely measured and blended. The scale of seasoning operations in a large chip factory is staggering. On average, a single factory might use over 5,000 pounds of seasoning per day. That's enough to fill a small swimming pool. The most popular flavors like BBQ, sour cream and onion, and classic salt continue to dominate, but there's a growing trend towards more exotic and region-specific flavors. As our chips tumble through the seasoning drum, the anticipation builds. Which flavor will they become? Will they join the ranks of classic salted chips, beloved by millions? Or perhaps they're destined for a more adventurous flavor profile, like jalapeno popper or loaded baked potato. The possibilities seem endless. The seasoning process is surprisingly quick, taking just a few minutes from start to finish. As the chips exit the drum, they pass under a series of sensors that measure the amount and distribution of seasoning on each chip. Any chips that don't meet the exacting standards are quickly removed from the line. Finally, our chips emerge from the seasoning station, transformed once again. They've gone from plain golden crisps to flavor-packed snacks, bursting with taste. The fine dusting of seasoning clings to every curve and crevice, promising a burst of flavor with each crunch. But the journey isn't quite over yet. These perfectly seasoned chips now face their final challenge before being packaged and sent out into the world. They must pass through rigorous quality control measures to ensure they meet the high standards consumers expect. As our hero chips move towards the quality control station, they carry with them the culmination of a long and complex journey. From humble potato to crispy, flavorful snack, they've survived washing, slicing, frying, and now seasoning. But will they pass the final test? The tension builds as they approach the last hurdle standing between them and their destiny in the hands of eager snack lovers everywhere. You might think you know what makes a perfect potato chip, but the standards at this factory would surprise even the most discerning snack connoisseur. As our chips approach their final evaluation, they're about to encounter technology so advanced it can detect imperfections smaller than a grain of salt. The quality control area of the factory is a gauntlet of high-tech equipment and eagle-eyed inspectors. Here, our chips face a series of tests so rigorous that even the slightest flaw could mean rejection. The process begins with visual inspection, where high-speed cameras capture multiple images of each chip as they move along the conveyor belt. These images are instantly analyzed by sophisticated software that checks for proper size, shape, and color. Color is particularly crucial in chip quality. The ideal chip should have a uniform golden brown hue without any dark spots that could indicate overcooking or light areas suggesting undercooking. The color analysis is so precise that it can detect variations invisible to the human eye. Chips that fall outside the acceptable color range are swiftly removed from the line by automated air jets. Next comes the texture test. While humans might judge a chip's crunchiness by eating it, The factory uses sound analysis technology. As chips pass through this station, they're subjected to gentle pressure that causes them to produce a subtle cracking sound. Microphones pick up this sound, and software analyzes its frequency and duration. A chip with the perfect crunch will produce a specific acoustic signature. Those that don't make the grade are quickly dispatched from the production line. Flavor testing presents its own unique challenges. While it's impractical to taste every chip, random samples are regularly pulled for human taste testers to evaluate. Additionally, advanced spectrometry technology is used to analyze the chemical composition of the seasoning on each chip, ensuring it matches the intended flavor profile precisely. The technology used in this quality control process is truly remarkable. Laser and X-ray systems scan for foreign objects that might have somehow made it this far in the process. These systems can detect objects as small as 0.8 nm, about the size of a grain of salt. Any chip with even the tiniest foreign particle is immediately rejected. The standards are incredibly high, and the percentage of chips that fail quality control might surprise you. On average, about 2 to 3% of chips are rejected during this final inspection. While this might seem like a small number, when you consider that a large factory can produce millions of chips per day, it adds up to a significant quantity. As our hero chips move through this inspection process, the suspense builds. Will they meet the exacting standards required to make it into a bag? They've come so far, surviving the washing, slicing, frying, and seasoning processes. Now, in these final moments, their fate hangs in the balance. The chips pass under the watchful eyes of the color cameras, their golden hue scrutinized down to the pixel. They move on to the texture analysis, their delicate structure tested for the perfect crunch. The flavor sensors analyze their seasoning, ensuring they carry just the right amount of taste. Finally, they pass through the foreign object detection system, a last check for any unwanted intruders. Moments later, the results are in. Our hero chips have passed with flying colors. They've met or exceeded every standard, proving themselves worthy of bearing the brand's name. As they move past the quality control station, they join the elite ranks of chips deemed perfect enough for packaging. But their journey isn't quite over yet. The final step awaits: packaging for the journey to consumers. As our chips move towards the packaging area, they carry with them the assurance of quality that comes from passing such rigorous tests. Soon, they'll be sealed into bags, ready to bring crunchy satisfaction to snack lovers everywhere. The transformation from humble potato to premium chip is nearly complete, with just one last stage to go. As our chips approach the packaging area, they're about to enter a world where time is measured in milliseconds and precision is paramount. Here, in the final stage of their transformation, they'll be sealed into bags at speeds that would make your head spin. But there's a catch. How do you ensure that delicate, crispy chips remain intact when they're being hurled into bags at breakneck speeds? The packaging area of the factory is a marvel of modern engineering. Rows of gleaming stainless steel machines stand ready to receive our freshly made chips. These aren't your average packaging machines. They're high-speed marvels capable of filling, sealing, and labeling hundreds of bags per minute. The air hums with the constant whir of machinery, punctuated by the rhythmic sound of bags being filled and sealed. But packaging these delicate morsels presents a unique challenge. Potato chips, for all their crispy goodness, are incredibly fragile. The slightest mishandling can turn a perfectly formed chip into a pile of crumbs. The packaging process must be gentle enough to preserve the integrity of each chip, yet fast enough to keep up with the factory's massive output. To achieve this delicate balance, the packaging machines employ a variety of innovative technologies. Vibrating conveyors gently move the chips into position, minimizing the risk of breakage. Precision weighing systems ensure that each bag contains exactly the right amount of chips, not a gram more or less. As the chips fall into the bags, cushions of air help to soften their landing, further reducing the risk of breakage. But it's not just about getting the chips into the bag intact. Maintaining freshness is equally crucial. The bags themselves are marvels of material science, designed to keep chips crispy and flavorful for weeks or even months. Multiple layers of specially designed polymers create a barrier against moisture and oxygen, the sworn enemies of chip freshness. Just before sealing, each bag is injected with a precise mixture of nitrogen and carbon dioxide. This process, known as modified atmosphere packaging, replaces oxygen in the bag with inert gases. It's this gas mixture that creates the signature puff. When you open a bag of chips, And more importantly, it dramatically extends the shelf life of the product. The speed at which all this happens is truly mind-boggling. In a large-scale chip factory, packaging lines can fill up to 200 bags per minute. That's more than 3 bags every second. To put this into perspective, in the time it takes you to read this sentence, dozens of bags have been filled, sealed, and are ready for distribution. As our hero chips approach the packaging machine, the anticipation builds. Will they survive this final gauntlet? In a blur of motion, they're weighed, dropped into a waiting bag, and sealed in a fraction of a second. The newly filled bag emerges from the machine, bearing the familiar branding that consumers know and love. But the journey isn't quite over yet. The filled bags pass through one final quality check. Metal detectors and X-ray machines scan each bag, ensuring no foreign objects have snuck in during the packaging process. Weight checkers verify that each bag contains the exact amount promised on the label. Finally, our chips, now safely ensconced in their protective packaging, are ready for distribution. They've completed their remarkable journey from humble potato to crispy flavor-packed snack. As they're boxed up and loaded onto trucks, ready to be shipped to stores across the country, there's a sense of accomplishment. These chips have survived every challenge thrown their way, emerging as a testament to the marvels of modern food production. Yet, as we marvel at the efficiency and precision of this packaging process, a question looms. All these bags, all this packaging, what impact does it have on our environment? As consumers become increasingly environmentally conscious, the chip industry faces a new challenge: how to balance the need for freshness and convenience with the imperative of sustainability. The journey of our chips may be complete, but the story of chip production continues to evolve, driven by the changing demands of consumers and the pressing need for more sustainable practices. The crisp, satisfying crunch of a potato chip comes at a cost, and not just the price on the bag. As we peel back the layers of chip production, we're faced with a sobering question: can our love for this salty snack coexist with environmental responsibility? The answer might surprise you, and it's reshaping the future of the entire industry. While we've marveled at the journey of our potato from field to bag, there's an untold story behind every chip, one of resource consumption and environmental impact. Large-scale chip production, for all its efficiency and innovation, poses significant challenges to our planet. The very processes that bring us these beloved snacks also contribute to water scarcity, energy consumption, and waste generation on a massive scale. Consider this: a single chip factory can use as much water in a day as a small town. The washing and processing of potatoes, critical for food safety and quality, requires enormous amounts of water. Energy consumption is equally staggering, with the high-temperature frying process and continuous operation of machinery demanding a constant supply of power. Then there's the packaging. Millions of non-biodegradable bags produced daily, many of which end up in landfills, or worse, in our oceans. Yet, the economic benefits of chip production can't be ignored. The industry provides jobs, supports agricultural communities, and contributes significantly to local and national economies. This creates a complex balancing act between environmental stewardship and economic necessity. Faced with these challenges, the chip industry is not standing still. Innovative solutions are being implemented across the production chain to reduce environmental impact. Water recycling systems are becoming increasingly common, with some factories able to reclaim and reuse up to 80% of their water. Energy-efficient machinery and renewable energy sources like solar panels are being integrated into factory operations, significantly reducing carbon footprints. Waste reduction is another area of focus. Potato peels and other organic waste are being repurposed as animal feed or converted into biofuel. Some companies are experimenting with edible packaging or biodegradable materials that break down harmlessly in the environment. These initiatives not only reduce waste, but also create new value streams, turning what was once considered trash into valuable resources. Recycling programs for chip bags are also gaining traction. While the multi-layer packaging that keeps chips fresh poses recycling challenges, some manufacturers are partnering with specialized recycling firms to process these materials. Consumers are encouraged to participate in these programs, turning empty bags into new products like park benches or outdoor furniture. Despite these efforts, the struggle to balance production and sustainability continues. The sheer scale of chip production means that even small improvements can have significant impacts, but there's still a long way to go. The industry faces ongoing pressure from consumers and regulators to further reduce its environmental footprint. Innovative solutions continue to emerge. Some companies are exploring alternative cooking methods like air frying, which could dramatically reduce oil usage and energy consumption. Others are investing in precision agriculture techniques to grow potatoes more efficiently, reducing water and pesticide use in the fields. There's even research into developing potato varieties that require less water to grow and less oil to fry, potentially transforming the entire production process. As consumers, we play a crucial role in this industrial ecosystem. Our choices, from the brands we buy to how we dispose of packaging, send powerful signals to manufacturers. By supporting companies committed to sustainability and participating in recycling programs, we can drive positive change in the industry. The journey of our chips, from potato to bag, is a testament to human ingenuity and technological prowess. Now, that same innovative spirit is being applied to the challenge of sustainability. As we enjoy our next handful of chips, we're not just savoring a snack, we're participating in an ongoing global effort to balance our love for these crispy treats with our responsibility to the planet. The future of chip production is being reshaped, one sustainable innovation at a time, and we all have a role to play in this transformation. As we've seen, the journey from humble potato to crispy chip is a marvel of modern engineering and precision. Every step, from field to bag, involves complex processes and cutting-edge technology. This everyday snack, often taken for granted, represents the pinnacle of food manufacturing innovation. Next time you open a bag of chips, consider the incredible voyage each crisp has undergone. From surviving industrial washing and slicing to navigating the perils of frying and seasoning, these chips are the result of countless decisions and processes. As we look to the future, we must ask ourselves, how can we balance our love for convenient snacks with the need for sustainable food production? The answer may shape not just the chip industry, but our entire approach to food in the years to come.